In this video, we're told we're trying to get the best deal on chocolates, and we're given these tags. We need to determine which one provides us the best deal. And specifically, we want to look at the unit ratios. And I'm going to go ahead and calculate the unit ratio for each one of these. And first of all, we have to set up a ratio. And we know a ratio is going to be a comparison of two quantities. So for this first $10 for 4 pounds, I'm going to write that in ratio form, like a fraction. And I'm going to use LB for the abbreviation for pounds. And I'm going to go ahead and actually write this for each one of these. These are the ratios that I'm constructing to describe the relationship between, in this case, the quantity in terms of dollars and the quantity relating that to a quantity of pounds. So we can construct ratios to represent the relationship here. And although you might be able to look at these and think about, even within informally think about which one of these could present the best deal, we want to look at the unit ratios. And to do that, we are just going to do the division that is set up in this ratio, in each one of these ratios. So if I take $10, 10, and divide it by 4, I get 2.5. So I'm going to write that here, 2.5. And it's really, we know that division problem gives us 2.5, but this is not just 2.5, it actually gives us a unit as well. We have to think about what is the unit. Well, we're taking a dollar amount and we're dividing that dollar amount by pounds. So what this is telling me, this is $2.50 for 1 pound. And I'm just going to write it one more time in a different way. $2.50 in this case over 1 pound. So all three of these represent this ratio in a simplified manner. It's $2.50 for each pound, or per 1 pound. And again, you can just do the division, but let's think about the units as well. If you want to pause the video and go ahead and find the unit ratios for each one of these, please do. I'm going to give you a second. I'm going to just write them all out right now. So I went ahead and calculated the unit ratio, and we know it's a unit ratio because we're just doing the division. And if we wanted to write it in ratio form, we have this bottom line here. And if we want to really think about how we might see it in a grocery store or at a market or somewhere, it probably is going to look like this second row. But it's presenting the same information. I did the division for $8.49 for 3 pounds, and I got $2.83. And the unit is dollars per pound. It cost me $2.83 per pound. For the next set of chocolates, it would cost me $2.30 per pound, and I got that just by dividing these numerals here, 1150 by 5. And finally, the last tag, the yellow tag, we have $3.80 divided by 2 pounds gives me $1.90, and the unit is dollars for each pound. Now looking at this, if we wanted to address the question above, which product gives us the best deal, we need to think about this. Which one is going to be the best deal? Well, I want to pay, in this case, if I'm trying to buy chocolates, I don't want to pay that much for each pound. So in this case, I would make the argument that this last unit here, or ratio, $3.80 for 2 pounds, gives me the best deal because each one of these is the price for 1 pound. And this last tag has the least amount of money here, $1.90 per pound. The most expensive chocolate is the green tag, $2.83 per pound. So we have to think about which is the best deal. Well, the units are telling us dollars per pound. That's going to give me the best deal, $1.90 per 1 pound. The next question that we're asked is to find the inverses of these ratios. And what I mean by that is, what if we flipped the units? We know a ratio could be set up in this manner, dollars over pounds, but what if we wrote it instead 4 pounds over $10. And over here we wrote 3 pounds over $8.49. What would we get if we simplified these? So I'm going to finish writing these ratios, and we're calling them the inverses because the quantities are inverted. I'm going to go through each one of these, and I'm going to find these unit ratios. So if you want to pause the video and do that, I'm also going to round to the hundredths place. So I went through and found the unit ratio. I just did the division, 4 divided by 10, 3 divided by 849, and so on. And I got these values here. So 0.4, 0.35, 0.43, and 0.53. We really need to be thinking about the units on these. And if we divided 4 pounds, we've divided a quantity of pounds by a quantity of dollars, then the quotient that we get, 0.4, has a unit of pounds per dollar. This is telling us the number of pounds we get for each dollar we spend. So we get 0.4 pounds for every $1. We get 0.35 pounds of the green candy for each dollar. We get 0.43 pounds for the red candy for each dollar. And finally, the best deal is 0.53 pounds for each dollar. That's the yellow tag. Now, why is it? We know the yellow tag's the best deal, but if you look down here, you're saying, well, that's the largest number. I thought we were looking for the smallest number. Well, again, this is where you have to be conscious of the units. Up above, the best deal was being represented as the smallest amount because we were looking at dollars per pound. We wanted to have the smallest number of dollars for each 1 pound. Down below, it turns out the inverse of that is pounds per dollar, and the best deal gives us the largest amount, and that should make sense. You want to get more pounds for each $1 spent. So this is really important, and it illustrates that you can't just go by the largest value or the smallest value without considering the units and thinking about what the units are actually telling you for that situation.